Hello students, this is Latif sir. Today I'll discuss about ICSE class 11 chemistry, the second chapter, structure of atom. On this chapter, this is my third period or third class. Before summer vacation, I have taken two class. This is third class. Today I'll discuss about spectrum. What is spectrum? You have seen that when sunlight is passed through a prism, the seven color of sunlight, white light, that is white light, separated or splitted to give a spectrum, which is called Vibgyor. You have seen that this one. Okay, just remember. So spectrum. What is spectrum? When a white light is passed through a prism, the wave with shorter wavelength bends more than the one with a longer wavelength. Since ordinary white light consists of waves with all the wavelength in the visible range, array of white light is spread out into a series of colored bands, which is called spectrum. That is the seven color of white light splitted to give a band which is called a spectrum when the white light is passed through a prism, and the light of red color which has longest wavelength is deviated the least, while the violet light which has shortest wavelength is deviated the most. Now types of spectrum. I think you have understood that what is spectrum. Huh. Spectrum is band of color. Band of color when the white light is passed through a prism, then you will get a band of color which is called spectrum. Now types of spectrum. There are two types of spectrum mainly. One is emission spectrum, other is absorption spectrum. Emission spectra is noticed when the radiation emitted from a source is passed through a prism and then received on the photographic plate. Emission spectrum is noticed when the radiation emitted from a source are passed through a prism and then received on a photographic plate. And radiation can be emitted in a number of ways, such as from sun or glowing electric bulb, or by passing electric discharge through a gas at low pressure, or by heating a substance to a high temperature. So these are source of radiation. huh. When this radiation is directly passed through a prism, you will get a emission spectrum. Now two types of emission spectrum: continuous spectrum and line spectrum. What is continuous spectrum? When a ray of white light is analyzed by passing through a prism, it is observed that it splits up into seven different uh, bands, white bands of color, from violet to red, like rainbow. This is the continuous spectrum, and these seven colors are so continuous that each of them merge into the next. That is, there is no difference or gap between two colors. Hence, the spectrum is called continuous spectrum. And in case of now, the second type of emission spectrum is line spectrum. When the vapor of some volatile substances are allowed to fall on the flame of Bunsen burner and then analyzed with the help of spectroscope, some specific colored line appear on the photographic plate, which are different for different substances. So these are this type of spectrum is called line spectrum. So when the vapor of some volatile substances are allowed to fall on the flame of a Bunsen burner and then analyzed with the help of spectroscope, you will get a line spectrum. Some specific colored lines appear on the photographic plate which are different for different substances. For example, sodium or its salt, that is sodium chloride, emits yellow light, while potassium or its salt gives out violet light. The spectra of hydrogen atom is also one type of line spectrum. Okay, and second type of spectrum is absorption spectrum. And when absorption spectrum is formed, when the white light is passed through the vapor of a substance, through a solution, through a transparent gas, or through a transparent liquid. When the white light passes through the vapor of a substance, and the transmitted light is then allowed to strike a prism, dark line dark lines appear on the in the otherwise continuous spectrum. The dark line indicates that the radiation corresponds to the corresponds to them corresponds to them were absorbed by the substance from the white light. This spectrum is called absorption spectrum. So when white light is passed directly through prism, you will get continuous spectrum, which is also emission spectrum. But when you pass a white light through a gas or through a vapor of substance or through a transparent liquid, you will get absorption spectrum. And in this spectrum, you will see some dark line in a continuous spectrum. This absorption spectrum is actually a continuous spectrum, but there are some dark line found in the continuous spectrum. And this spectrum is called absorption spectrum, and the dark line appears exactly at the same position where the lines in the emission spectra appear. Here, see the figure. First one, image of continuous spectrum, second emission spectrum, and third absorption spectrum. Continuous spectrum and line spectrum are types of emission spectrum. That is, emission spectrum are two types. One is continuous spectrum, another is emission spectrum. And continuous spectrum is formed when white light, that is sunlight or light produced from glowing bulb, is passed through passed through uh, through a prism. You will get continuous spectrum. Second, the light produced from hot gas, that is light produced from hydrogen gas present in a discharge tube. Hmm. When this light or radiation produced from hot gas or excited gas, that like hydrogen, uh, and the radiation when passed through a prism, you will get line spectrum, that is emission spectrum. Hmm. So you can see here the line spectrum. And third is absorption spectrum. In case I have told that in case of to obtain a absorption spectrum, you have to pass the light through a transparent liquid or through a gas. And when the light passing through the gas, cold gas or transparent liquid, some of the wavelength, some wavelength of the light are absorbed by the cold gas or by the transparent liquid. That's why in the absorption spectrum there are some dark line. That is some when the light passing through the cold gas, some light of a specific wavelength are absorbed by the cold gas or transparent liquid, and these wavelength are not appearing in the absorption spectrum. So absorption spectrum is actually a continuous spectrum, but there are some dark line. Okay. Now line spectrum of hydrogen. I have told that line spectrum of any element is one type of emission spectrum. And how to get the line spectrum of hydrogen? You have to take some hydrogen gas in a discharge tube, and then you have to pass current or electricity through the hydrogen gas in the discharge tube. And after some time, you will see that when the first when you are passing current through hydrogen gas present in the discharge tube, there are uh, lots of hydrogen atoms, and all hydrogen atoms become excited. And when this hydrogen atom again uh, when this hydrogen atom radiates the energy, then you will get a spectrum of hydrogen atom. That is radiated energy, that is radiated light uh, from hydrogen atom. When you pass this light through a prism, you will get line spectrum of hydrogen. So when electric discharge is passed through hydrogen gas enclosed in a discharge tube under low pressure, the emitted light is analyzed by a spectroscope. The spectrum consists of large number of lines which are grouped into different series, and the complete spectrum is known as hydrogen spectrum. Hydrogen spectrum is a line spectrum. It is actually a emission spectrum. Here you can see like this hydrogen spectrum, also like this uh, emission spectrum. Okay. And if you see the figure 2.8, it is actually a atomic spectrum of hydrogen. There are different series of line. You can see the complete figure is a uh, atomic hydrogen spectrum. On the basis of experimentally observation, scientist Rydberg noted that all series of line in hydrogen spectrum could be described by the following expression. That is, uh, wave number nu bar is equal to what is nu bar? Nu bar is the number of waves per unit length of the wave. Number of complete wave per unit length of the wave. So nu bar is equal to 109677 into 1 by n1 square minus 1 by n2 square centimeter inverse. Actually, why we get this atomic spectrum of hydrogen? Because due to large number of electronic transition from higher excited state to lower ground state, electronic transition from excited energy level to ground energy level. When electrons radiate their energy, it becomes uh, it releases when it releases energy, it reaches to ground state. and the light or radiation emitted by electron present in hydrogen atom. When this energy pass through when this light is passed through a prism, you will get a spectral line. You can see here, hydrogen generally hydrogen atom has one electron in first cell. This is the ground state. But when you passed electricity through hydrogen gas, the electron become excited. That is, uh, electron moves to higher energy state. That is n equal to second cell or third cell in fourth cell or in fifth cell. It depends how much energy is getting from the electric current. Okay, so first hydrogen atom become excited. That is, electrons move into higher energy level, and next after that, when hydrogen radiates energy, it come back into lower energy level. That is lower energy cell. And when electrons moves to lower energy level, it radiates energy. And for this radiation, we get the spectrum of hydrogen. Here in this figure, you can see when electronic transition occurs from n equal to second cell to first cell, third cell to first cell, fourth cell to first cell, fifth cell to first cell, sixth cell to first cell, uh, seventh cell to first cell, or infinity cell number infinity to first cell, you will get a line spectrum which is called Lyman series, which is called Lyman series. And when electronic transition or electron moves from third cell to second cell, fourth cell to second cell, fifth cell to second cell, sixth cell to second cell, like this, uh, then you will get Baumann's as a line of spectrum which is called Baumann's series. When electron moves from fourth cell to third cell, fifth cell to third cell, sixth cell to third cell, seventh cell to third cell, you will get a series of line which is called Paschen series. Hmm. And when electrons moves from fourth cell to fifth cell to fourth cell, sixth cell to fourth cell, seventh cell to fourth cell, you will get Beckett series. And when electronic transition occur from sixth cell to fifth cell, seventh cell to fifth cell, eighth cell to fifth cell, like this, you will get Punt series or Punt series. Okay. So atomic spectrum of hydrogen consists of different series, and these series are called Lyman series, Baumann's series, Paschen series, Brackett series, and Punt series. And for all type of series, you can there is a mathematical expression. By using this expression, you can calculate the wave number of each type of radiation. So the mathematical equation is nu bar wave number is equal to 109677 into 1 by n1 square minus 1 by n2 square, where n1 is the n1 is 1 2 3 4 5 6 7, and n2 is n1 plus 1. If n1 is 1, then n2 is 2 3 4 5. If n1 is 2, then n2 is uh, n2 is 3 4 5 6 7, like this. If n1 is 3, n generally n1 is the lower energy cell, and n2 is the higher energy cell. Here, scientist Rydberg in 1890 has given the simple theoretical equation for the calculation of wavelength and wave number of the spectra line in different series of hydrogen spectrum. And the equation is known as Rydberg formula or equation. And the Rydberg equation is 1 by lambda. Lambda is the wavelength of radiated light from hydrogen atom. So 1 by lambda is equal to 1 by lambda is also is equal to nu bar. Nu bar means wave number. Wave number is equal to 1 by lambda. So 1 by lambda is equal to nu bar is equal to RH into 1 by N1 square minus 1 by N2 square, where RH, or sometimes it is written as only capital R, which is called Rydberg constant, and the value of RH or R is 109,677 centimeter inverse, and N1 and N2 are electronic transition occurs from N2 energy cell to N1 energy cell, where N2 is higher energy cell and N1 is lower energy cell. And this equation is valid for only hydrogen atom. And for other hydrogen-like atom or ion, the equation becomes 1 by lambda is equal to 1 by wavelength is equal to wave number, that is nu bar is equal to R into Z square into 1 by N1 square minus 1 by N2 square, where Z is the atomic number of the species of the atom or of the ion, and R or RH is a constant which is called Rydberg constant, and value of N2 always is higher than value of N1. So in case of hydrogen, line spectrum of hydrogen or atomic spectrum of hydrogen, there are total 5 series. One is Lyman series. In case of Lyman series, the value electronic transition occur from n equal to 2, n2 is equal to 2, 3, 4, 5, 6, 7, 8 to n1 is equal to 1. In case of Balmer series, electronic transition occur from n2 is equal to 3, 4, 5, 6, 7, 8, 9, etc. to n1 is equal to 2. In case of Paschen series, n2 is electronic transition occur from n2 is equal to 4, 5, 6, 7 to n1 is equal to 3. In case of bracket series, electronic transition occur from n2 is equal to 5, 6, 7, 8, 9, 10 to n1 is equal to 4. And in case of font series, electronic transition occur from n2 is equal to 6, 7, 8, 9, 10 to n1 is equal to 5. Okay, so due to this large number of electronic transition in hydrogen atom, in large number of hydrogen atoms, we get the line spectrum of hydrogen atom, that is a different series of hydrogen atom. Thus, by substituting the values of N1 and N2 in the above equation, that is nu bar is equal to R into 1 by N1 square minus 1 by N2 square, wavelength and wave number of different spectral line can be calculated. When N1 is equal to 2, the expression given above is called Balmer formula. Okay. And the spectral line of hydrogen, the different series of spectral line for hydrogen are found in different region of light, different region of electromagnetic radiation. The Lyman series, in case of Lyman series, N1 is equal to always 1 and N2 is 2, 3, 4, 5 up to infinity. And Lyman series is found in ultraviolet region of light. Balmer series is found in visible region of light. In case of Balmer series, N1 is equal to 2, N2 is equal to 3, 4, 5, 6 up to infinity. In case of Paschen series, N1 is equal to 3 and N2 is equal to 4, 5, 6, 7, 8. And Paschen series is found in infrared region of light. Bracket series is found it's also in infrared region of light. In case of packet series, n1 is equal to 4 and n2 is equal to 5 and 6. 5, 6, 7, 8 like this. And in case of phone series, n1 is equal to 5 and n2 is equal to 6, 7, 8, 9, 10. And phone series or phone series is found in IR region of light. Okay, thank you.